Example 29b is telling us to calculate the sum of the series given on the screen, which has a terminating term. So they're giving us the last term. Now, what I need you to see is that the numbers have a pattern, but the pattern is irregular, or it's a regular wrong pattern, right? So it's 3, 2, 9, 2, 15, 2, 21, 2. And what you notice is every second term is 2, right? So that is going to be your clue that you are dealing with a mixed series. So if every second term is 2, we can take those out, right? So our first series, our second series, can be 2 plus 2 plus 2 plus 2 ellipses. And then we have the other one, which is 3, 9, 15, 21. And eventually that 597. So we know that 597 is blue because the yellow one is all 2's, right? So let's write this one out. Our second series is 3 plus 9 plus 15 plus 21 plus ellipsis plus 597, period. Okay, these are our two series. Now what do we need to do? We need to figure out the sum of the series. Do you remember that in order for us to do an SN, the question is sum, so we need an SN answer. But in order to answer this, we need to know what is N. We need to know what is A, what is D or R, and we need to know what is N. And the problem right now that we have is we know that this is N, but we don't know what it is. So we need to first start by asking ourselves, what is Tn and of which one? Pardon me. So because N is blue, we're going to do the Tn of the blue formula, right? Or the blue series. So let's go and we'll say, okay, what is Tn? Tn of the blue. Oh, wait. How do you know? What are you doing? Are you doing arithmetic or geometric? So let's see. If I wanted to go from 3 to 9, I can do two things. I can either say 3 plus 6, or I can say 3 times 3. The first one is arithmetic, and the second one is geometric, right? So I need to decide which one is it going to be. I can either plus, the same thing, or times, the same thing. So let's do the second one, and I can say, okay, 15 minus 6 is 9. Okay, plus 6 works, but 9 times 3 does not work because that gives me 27. So at this point, I know that D equals 6 and that this is arithmetic because that works and that does not work. And they will not both work. So happy days, we're working with an arithmetic series. So now, what is the Tn of arithmetic? This is equal to A plus n minus 1 times D. Let's substitute. A is 3. N is, what we're trying to solve. So n remains unknown, Tn. And D is 6. Okay, so Tn equals A plus n minus 1 times D. Let's solve. Oh, but we know what Tn is because we said that this last one is n, right? So if this last one is n, this is 597. So far, so good. Okay. Why did I put A in there? We need a number. That number is 3. Okay. So now we can solve, and what we want to do is we are going to multiply this D into the bracket, distribute, and we're going to say 597 is equal to 3 plus 6n minus 6. Simplify, 597 is equal to 6n minus 3. Now we want n alone. So what we're going to do is, so what we did here was add like terms. Now we're going to take this to the other side. So plus 3 on both sides. 597 plus 3 should give you 600 is equal to 6n. Get rid of this 6. Multiplication, opposite is division. Divide by 6 on both sides. N is equal to 100. Okay, so we know now they are 100 terms. Okay, this n, this last one is going to be term 100. Yes, we know. Okay, great. So this is term 100. Great stuff. Okay, now what are we gonna do? We want the sum of n terms. But, let's see. Oh, good question. So now, is it? I don't think that this one is 100. I think on this, hold on. So this n on the Tn actually refers to the blue sequence. There are 100 items in the blue sequence. Okay, so let's sum the blue sequence. Okay, so now we're going to do the Sn of the blue sequence, and we said this is arithmetic. So as an arithmetic sequence, it's going to be n over 2 square bracket 2a plus n minus 1 times d, right? So that means S of our n here is 100. S of 100 is equal to 100 over 2, open bracket, 2 times a, 2 times 3. If you look on the blue one, a is 3, plus 100 minus 1 multiplied by a difference of 6. And pop that into the calculator. We get 100 over 2. That's not 100. 100 over 2, bracket 2, open 3, close, plus open 100 minus 1, close, 6, close. And that gives us a total of 30,000. So S of 100 on the blue sequence is going to be 30,000. That's too many zeros. Okay, now what about the yellow one? We know that the yellow one consists of 2's only, right? And those 2's will end 1 before n. So the last yellow term is going to be n minus 1, and n is 100. So there are 99 terms on the yellow one. Okay, so now we're going to say, okay, we know that n equals 99 for the yellow one, just based on the logic we just discussed now. And then we're going to say, okay, the sum of these 99 terms is going to be equal to what? Now remember that each term is the same. It's 2, 2, 2, 2, 2, 2, 2, 2, 2. So we're going to say it's 2 multiplied by 99. And that means that the S of 99 here is going to be equal to 2 times 99, 198. That's the yellow one. The sum of the yellow plus the blue. So now we're going to add these two together, and we're going to say 30,000 plus 198 gives us 30198. That is the total of this entire sum.